All right, next we are working with aminobenzene. So first we're gonna make a benzene. You just do it like this. Oh, I messed up. Okay, we now have a benzene like this. And that, we can just place one on top here. This is telling us that we are connecting with an amino acid. I forgot what it is. It's one of these two. That's one I tried. Oh no, it's this one. It's like that. So it's connecting with an amine, which is NH2, and then you just have the benzene on the bottom right there. Next we have benzoic acid. So first we get our benzene, and then a benzoic acid looks like this. Wait, no, it's not. It's like this. That's what benzoic acid is, a benzene combining with a single carboxylic acid, which is like this. So it's like a methyl going out and then connecting singularly to an OH and a double bonding to an O. That one's confusing. I don't think you'll see that on the test. Next we have a bromobenzene. This one's easier. Make the benzene and then just add bromine to the end like that. That one's pretty simple. Next we have 1 bromo, 3 methylbenzene. So first construct your benzene. And then since we have no real start, wherever you put your bromine, that's where we'll start. So this is now our 1. Our methyl is at 3. So we go 1, 2, 3. And we just add the methyl right there. Like that. For this one's kind of confusing. But we'll figure it out. Okay. This one, it's a benzene, so we're starting with benzene. And we have 1, 2, 3. We have benzene. We start here, because remember the ethyl is always first, so we could do 1 and 3 is where our 2 ethyls are. So 1, 3, ethyl. And remember diethyl, because there's 2 of them. And then we put, after that, a 1 methyl. So our methyl would be at 2 methyl, like that. Okay, next we are working with bonds, or reactions. So reactions, for many of the reactions, if it were not adding heat or anything, let me go to them. High information reaction. Okay. So we have our reactions here. We have hydrogenation. Hydrogenation, we're adding hydrogen and we're removing the double bond. These reactions only happen in alkenes where there's double bonds. It's not happening in alkanes with singular bonds or alkynes where there's triple bonds, only in alkenes. So since our byproduct is just hydrogen, we don't need to add anything else because hydrogen's already implied being on lines like these. So basically what this is saying is we're just getting rid of the double bond. So basically just redraw it without the double bond. This one is the same thing, hydrogenation reaction. So just recreate it. 1, 2, put one down there, like that. Okay. This one is not a hydrogenation reaction. It is a hydration reaction. And that means that the byproducts are going to be H and OH, where the double bond was. That's important. The H and OH are going to be where the double bond was beforehand. So we're constructing what was beforehand. And if it's over here, that means that this will be the O, or I mean the H, and this will be the OH, like that. Okay. So those are hydration reactions, like that. We have Br2. So this is a halogenation reaction. That's where there's two of the halogen is telling us these are halogens, or the ones that are in the 7th column. And like these are like chlorine, bromine, fluorine, like those, like that. So chlorine here. This is telling us that it's going to get rid of the double bond, and then where the double bond is removed is replaced with the whatever is being bonded with it. So like 2 chlorines. So here, first redraw it without the double bond. So we have 1, 2, 3, 4, like that. And then where the double bond was, the bond is right there. We add a bromine, remember? And then another bromine, like that. Okay, cool. And this one, we're doing an addition reaction. But there's chlorine here, so we're working as a halogenation reaction. So what that tells us is that 2 chlorines are going to be added, and our double bond is being removed. So this is going from an ene to an an. This one doesn't have an an at the end. This one doesn't. This one doesn't. This one doesn't. So automatically we can know this is this one, because that one is only with the an. Because remember, reactions take away the double bonds. But since it's being added to chlorine, we put the dichloro in there. And remember, it's cyclo, so dichlorocyclohexane. And the chlorines have to be next to each other, because just like how we saw in the last one, the chlorines are going to get added next to each other. So we missed that one. Next, we have ethyl cycloheptane. So heptane first, we do a 7-sided shape. So it'll give you how to do it. So we have a 7-sided shape like this. And remember, cyclo, which means that it has to be a close shape. And then we have ethyl. It's not telling us where it's at, so that just tells us that we add it anywhere, and it'll be fine. I mean, wait, ethyl. Sorry. Ethyl is 2, like that. It's branching. Okay. Now we have propyl. Propyl is 3. Propyl is like this. That's what propyl looks like. And then now we can just make a hexane, and that gives our answer like that. So remember, methyl is 1 line, ethyl is 2, propyl is 3 lines. Okay, the reaction of an alkane with oxygen to produce carbon dioxide and water is known as what? We have to go back a little bit. There were some other reactions that were given. Where are they at? I always miss them. Okay, here they are. So reactions of alkanes. We have a combustion reaction, and a halogenation. So this doesn't produce carbon dioxide and water. A combustion reaction does, carbon dioxide and water. So this is a combustion reaction. Okay, next, what are the products of combustion of isoctane? So combination or combustion, remember, products are always carbon dioxide, water, and heat. Carbon dioxide, water, and heat. Okay. And then now we're trying to find a combustion reaction with 2-methylpropane. 2-methylpropane is C4H10, because propane is C3H8, and then add the methyl, C4H10. And we add it with CO2 to get H2O, and we could just remove energy when we need it. So basically we have C4H10 plus O2 equals CO2 plus H2O. So with this, we have to do the stoichiochemistry and balance this out. So I'll save you the time. We put a 2 in front of here and put nothing in front of that one. No, we put like a 10 here, and then an 8 here, and then like a 10 here. So this tells us that it's asking for how many moles. Remember, the moles is this number in front of the compounds. How many moles of carbon dioxide? This is carbon dioxide. We have 8 moles. So our answer is 8. Like that. Okay, 2 more questions. We are looking at the type of reaction here. Remember, if we're ever working with a halogen is like everything in the 7th column. Or that's like fluorine, chlorine, bromine, all of those. It's going to be halogenation reaction. So this is halogenation. Last one. What is the product between cyclopentane and chlorine? Remember, chlorine is a halogen. Halogenation reactions. It's going to make it a ane, which it already is, so it has to be an ane. And then remember, removing the double bond is going to give us 2 chloros. So I guess it doesn't matter here. No, it's only going to give us 1 chloro because we're not removing the double bond. So, but the chlorine still is going to be added. So we have chlorocyclopentane, like that. Because the chloro gets added, and then you just keep everything else. So, and then that's it. Let me know if you have any questions. This one's not too difficult, but I know it went kind of fast. So just let me know, honey. I love you.